Hello, my name's Aaron. I do genetics at university, and today I'll show you how to get the properties of any protein that you want, and what you can do with that. So yeah, I'll be explaining that today. Here I just have a prepped protein that I already know of. Here it shows you the protein name. Oh yeah, but you're going to be using UniProt. I'll put all the websites in the description anyway. That's fine. Protein name. Its length in terms of amino acid residues. It's kind of like a medium-sized protein. A large protein would be like 1,000 or so. So this is fine. You can also use this later on. I'll explain. And the organism which it comes from, E. coli. E. coli, my best friend. I love this guy. Here we see a bunch of sections on the left. I normally just click on subcellus location first. This is pretty important. And we can see it comes from the periplasm. And this tells us two things. It is most likely glycosylated, and it is most likely soluble. This also applies if your protein is located in the endoplasmic reticulum. But this one is actually not glycosylated because E. coli doesn't have the machinery for any type of glycosylation patterns. So ignore that. That might trip you up actually, and we'll see that later. Then we'll go to post-translational modifications here, and we can see it forms disulfide bonds at this amount of residue. It would also show others if there were. Then we just go to structure, and you can see a cool little protein here. Looks pretty snazzy, pretty neat. So that's basically all the information you can find on UniProt. But sometimes they won't have subcellular location and post-translational modifications. So that's when you need to go to other websites. But first, you need to go up here, you click download, and then go to faster format. Click this button here. It should pop up with this tab, which shows you the full amino acid sequence. We highlight all this, Control C, and then Control V it into explicit, and then it should show you all the amino acid residues here. We see cysteine residues, so that gives you a hint that it might form disulfide bonds. Gives you its molecular weight, swag, if it's charged or not, its extinction coefficient. You can use this if you want to try and find its concentration in a solution by looking at its absorption rate. So this is pretty useful. Then we're going to go to another website, which is DeepTMHMM, and this tells you where protein is located. Is it outside? Is it transmembrane? Is it surface protein? But this shows you that it is mostly outside. But then here it shows that there is a signal peptide present, which is very interesting. Which tells you that it's secreted somewhere, right? And so then we go to signal P60, which shows you there is a high probability, pretty significant probability, that there's a cleavage site between 21 and 22. So that's when it turns into mature. I mean, no, that's like when the signal peptide is cleaved off, when it's done its job. Yeah, so it's already been secreted, and that's pretty cool at its end terminal. Yeah. Then final website that you can use is to look at its glycosylation patterns, and here the asparagine residues are highlighted in red. Here we can see there's one, but as I said earlier, E. coli has no glycosylation machinery, so this website can trip you up a little bit if you're not paying attention. Other than that, you should be fine. So yeah, that was an example for if it came from E. coli. Why is that significant? Why do we care? If you wanted to express this protein, you'd probably express it in the same strain of E. coli, right? Because it comes from there. It's native. You don't really have to do too much to it. Um, but if it was a human protein, right, you can't express it in E. coli because it doesn't have the right glycosylation patterns. Your final protein wouldn't perform the same. It would be useless protein. So that's when CHO cells or Chinese hamster ovary cells come in, and you'd express it um, in a culture of CHO cells, which is way more expensive. But yeah, this is how you basically get all the information of whatever protein you want to. If it is secreted by its signal peptide, as any post-translational modifications that might be useful to you, um, where it's located, all the cool things that comes with being a protein, I guess. Yeah, I hope this helps. Thanks for watching. Bye bye.